Okay, so in this video we're going to be solving Probability and Statistics Paper 1 of October-November 2022. This is variant 2. So let's look at the first question here. Now on the first question it says, on any day, Kino travels to school by bus, by car, or on foot with probabilities 0.2, 0.1, and 0.7 respectively. So the probability for bus is 0.2, car is 0.1, and on foot it is 0.7. So now the probability that he is late overall is 0.235. So now if we draw a probability tree right here, we would see that the probability that he's late when he's going by bus is 0.2 into x. The probability that he's late when he travels by car is 0.1 into 2x. And the probability that he's late when he's on foot is 0.7 into 0.25. So 0.7 into 0.25. Now all of this totals to 0.235. So if he's late by bus, if he's late by car, and if he's late on foot, all add up to 0.235, which is the total probability of him being late. So we put them in equation and we get 0.4x from adding this segment here, and from this we get 0.75. Now we solve the equation for x and we find 0.15. There we go, that is your value of x. And now we look at the next one, b. Now b tells us, find the probability that on a randomly chosen day, Kino travels to school by car, given that he is not late. Now how do we find out the probability that he is not late in total? We were given the value of him being late in total, which was 0.235, and we deduct that from 1, and we get the probability of him not being late. So he was not late, and he was going by car. So the probability that he was late when he was on car was 2x, which is 0.15 into 2, which is 0.3. Now, the probability that he was not late would be 1 deducting the probability that he was late. So 1 minus 0.3 equals to 0.7. So let's see, the probability that he was late, 1 minus 0.3 into the probability that he went by car. So we get this, which is the probability that he went by car, was not late, and then we divide by the total that he was not late. There we go, this value right here, and we get this fraction as a probability. Now the next question, question number 2, tells us the lengths of the rods produced by a company are normally distributed. So we're going to be using a normal distribution graph here, with means 55.6 millimeters and standard deviation 1.2 millimeter. Now the first question says, in a random sample of 400 of these rods, how many would you expect to have less than 54.8 millimeters? So we got our standard deviation, which is 1.2. We got our mean, which is 55.6. and we're given to find the probability of 54.8 or less. So we put them in the equation, which is the value that we got minus mean by standard deviation. So there it is. We find the value of the probability in the normal distribution graph. So this gives us the result 0.667, or rather minus 0.667. So this minus converts it to 1 minus probability 0.667 because of the minus sign present. So here we go. And the probability you can match on the normal distribution data table given to you in your question paper or in the data booklet to find it is 0.7477. So we find 0.47477 and we deduct it from 1. We get the probability 0.2523. Now, out of any total as given in the question here, which is 400, 0.2523 fraction of them would be less than 54.8. So we multiply 400 with our probability and we get 100 and 100.92. Now, since the number of rods cannot be in decimal, we round it off to 101 rods. Now, the next question tells us find the probability that a randomly chosen rod produced by this company has a length that is within half a standard deviation of the mean. So our value that we're going to be using here, x, would be either half a standard deviation more than the mean or less than the mean. So here we have the possible values of x. So for each value of x, we place them in the equation. All right, so we have our mean, our standard deviation, and we have mean plus 1 by 2 standard deviation, and this is minus mean. So minus and plus mean cuts out. We get half standard deviation by standard deviation, so that is half. And for mean minus half standard deviation, we get minus half. So we put both halves in the probability statistical table. So we compare them. We look for the value 0.5. And for the value of z is greater than half. And for the value of half, we find 0.6915. And now for the value of half, we get this equation right here, this half. And for the value of minus half, we get 1 minus p half. So we get this equation right here. So now we find this half right here. We find the probability all the way up to this, and we deduct the value of this half. So we deduct this from all of this to find this area of probability. So we deduct minus half from half, and we get, let's see what we get. So p half minus 1 minus p half. So here the when we remove the brackets, it becomes p half minus 1, and the sign changes, so it becomes plus half. So we get 2p half minus 1. Now we look for the value of 0.5 or half in the statistical table, and we get 0.6915. So this thing becomes 0.6915, and we put that in the equation. 2 into 0.6915 minus 1, so minus 1, and you get the probability of the rods being between less than half standard deviation from mean and more than half standard deviation from mean. And this will be your answer. Now, in the next question, 3 fair 6-sided dices, each with faces marked 1, 2, 3, 4, 5, 6, are thrown at the same time repeatedly. The score on each throw is the sum of the numbers on the uppermost face. Find the probability that a score of 17 or more is obtained on the 6th throw. So 3 dices are thrown, each have the possibility of being any number from 1 to 6. So we can perform geometric distribution here after we find the probability of how many possible ways we could get 17 or higher. So one possible way is we could get 6 on each dice, so we could get 18. We could get 5 on one dice and 6 on the other, so we could get a 17. Now the 5 could be on any one of the dices, and 6 could be on the rest of the dices. So the probability that we'll get 17 or higher is there are 4 possibilities, and as said here, 4 outcomes out of a total of 6 into the power 3. So 6 into the power 3 here, and that gives us 216. So the probability of 17 or more is 4 outcomes out of 216 possible ones. So that gives us 1 by 45. And now we need to find the probability that this happened on the 6th throw. So on the first few throws, it didn't happen. So on the first few throws, it was below 17. So to find the probability that it was below 17, we deduct the probability that it was 17 from 1. This is our probability of not 17. So the first 5 times it was a fail. It was not 17 or above. And on the 6th try, it was 17 or above. So we do the multiplication and we find 0.0169. This is our answer. Now in the next part it says find the probability that a score of 17 or more was obtained in fewer than 8 tries. So fewer than 8 tries, that means it was 7 tries or more. So how do we find that? Now we know to have found 17 on 8th throw or above 8th throw would mean to fail the first 7 times, right? So we find the probability that they failed, which was 1 minus 1 by 54, which would be 53 minus 54. Now remember, we found this value in the previous half of the question. So this is our probability of failing 7 times. So how do we find the probability that they did not fail 7 times? or the first 7 times rather. We deduct the probability that they did fail from 1. So the probability that they failed 7 times minus 1. So we get this equation right here, and if we put this in the calculator, you get the value 0.123, which will be our answer. Now in the next question, question number 4, we're given the time taken in minutes to complete a word processing task by 250 employees. So the total number of employees is 250, and this is the list of the time taken and the frequency of time taken by employees. So let's say 32 employees took between 0 and 20 minutes, 46 employees took between 20 and 40 minutes, and so on. So we're told to draw a histogram to represent this information. So first thing we gotta do is we gotta find frequency density. Now how do we do that? So we take the frequency, so let's say the frequency of the first one is 32, and we divide that by the class width. Now the class width here is the upper limit minus the lower limit. So 20 minus 0, we get 1.6. We do the same for the next one. So 40 minus 20 by 46 for this one, and we get 2.3. And we do this for every single data value. And now we draw the histogram. So on the histogram, we put frequency density on the y-axis, and we put range of time taken on the x-axis. So from 0 to 20, our frequency density is 1.6. So we put 1.6 here. From 20 to 40, our frequency density is 2.3. So we put 2.3 here. This corresponds to 2.3. And we do this for every single value until we have placed all the values. So for 40 to 50, we have the frequency density 9.6. So we put a bar on 9.6. From 50 to 60, we have 5.2. So 5.2 right there. 5.2. And for 40 to 60, we have 0.6. So the graph here corresponds to 0.6. Oops. Corresponds to 0.6 right here. And now in the next question, we're given that from the data, the estimate of the mean time taken by these 250 employees is 43.2. So we were given a mean, and we're told to find standard deviation. So the formula for standard deviation is minus mean square into x square f by sum of f. So we have sum of f, which is 250 because we have 250 employees. Now how do we find x? Now we're given a range of times, right? So what we do is we take the midpoint of the range. So from 0 to 20, we get 10 as midpoint. From 20 to 40, we get 30 as our midpoint. From 40 to 50, we get 55. So to find the midpoint, what we do is we add the two numbers, all right? We add the upper and lower limit of the range, and we divide them by 2. So 50 plus 60 by 2, you get 55. So midpoint is 55. So 160, we find the midpoint, which is again 100 plus 60 by 2, which would be 80. Now we have found our midpoints. Now we need to find x square f. So the way we find x square f is 10 square into frequency. Now the frequency for 0 to 20 was 32. So this would be 10 square into 32. Frequency for 20 to 40 was 46. So 30 square into 46. For 40 to 50, it was, let's take a look, it was 96. So 45 square into 96. 55 square, let's take a look at the frequency. It is 52. So 52, 80 square into 24. And then to find total of x square f, we add all these values and we divide them by, we add all these values. So this is our x square f, and we divide them by 250. So the formula x square f minus, we have found that f is 250, and mean square. So our mean square is given as 43.2, so we place 43.2 square in there, and we square root it, so to the power half, and we get the standard deviation 18.3. This will be our answer. Now the next question here is question number 5. Eric has 3 coins. One of the coins is fair. The other 2 coins are each biased, so that the probability of obtaining a head on any throw is 1 out of 4, independently of all throws. So one coin has a probability of half being head and half being tail. And the other 2 coins, independent of the throw of any other coins, they themselves have a probability of 1 by 4 of landing a head and 3 by 4 of landing a tail. So Eric throws all 3 coins at the same time, and we're given the conditions or events A and B. All 3 coins show the same result, is A, and B is that one of the coins shows a head at least. So we can find the probability of all the possible outcomes here. So let's say the probability that all land on a head are half for the fair coin and 1 by 4 for the 2 unfair coins or biased coins. So we multiply them all, we get 1 by 32. And we do that for all possibilities. Let's say one of them was a tail. So let's say one of the non-fair coins or the biased coins was a tail. We multiply the probabilities, we get 3 by 32. Now there are two biased coins, so if the other one was a tail and the previous biased coin was a head, we multiply the probabilities and we get a similar probability. Or let's say the fair coin was a tail and the rest of the two were heads. So we multiply the probabilities here and we get 1 by 32. Now, another possibility could be that one of the biased coins was a head and the rest were all tails. So the probability of the fair coin being a tail is half. The probability of the biased coin being a tail is 3 by 4, and of it being a head is 1 by 4. Multiply and we get 3 by 32. And another possibility we could get is one of the biased coins gives a tail, while the fair coin gives a tail as well, and one of the biased coins gives a head. So we multiply the probabilities of those happening independently, and we get the probability of them happening at the same time. Now, these are all probabilities where at least one of the biased coins shows a head. So we add all these probabilities and we simplify it and we get 1 by 16. So this will be our answer. Now, in the next part, we're told to find the probability that A is correct given that B is correct. So A is all three coins show the same result. So given that B is correct, now the probability that B is correct is 7 by 16, right? As we found in the previous question, 7 by 16. Now the probability that A is correct given that B is correct, we need to look for in the table here. So in the table where it shows all the possibilities of B being correct, which one shows all three coins showing the same result? So we can see only one. So that would be 1 out of 32 possible outcomes. So 1 out of 32. So the value of A being correct given that B is correct is 1 by 32 by 7 by 16, because the probability that A and B are both correct is 1 by 32 and the probability of B correct is 7 by 16. So we divide that, we simplify it, and we get 1 by 14, which would be our answer for this question. Now let's look at C of this question. The random variable in the number of heads obtained when Eric throws the 3 coins is X. So draw up a probability distribution for X. So the probability that we get no head, that we get 1 head, 2 heads, and 3 heads. So for 0, all of them would have to be tail, right? So this is the probability of the fair die being a tail. We multiply it with the probability that the 2 biased dices would be tails, and we get 9 by 32. So for 0, we get 9 by 32. Now we find the probability that one of the dice could be a head. So it could be that the fair dice could be a head and the other 2 dice could be tails, or one of the 2 biased dice could be a head. So we find the probability of the fair dice being a head, and we find the probability of one of the unfair dice or biased dice being a head. And since there are 2 possible outcomes for that, we multiply it by 2. So there we go. And we find the probability of one dice being ahead. Now, what about when two dice are heads? So that could mean that one of the dice has to be a tail. So it could be the fair die, or it could be one of the two biased dice. So you find the probability of the fair die being a head or a tail. So the fair has a half chance of being a tail, and the rest have 1 out of 4 chances of being a head. And we do that for the biased dice as well. And since there are two possible outcomes for that, we multiply by 2, and we get 7 by 32. Now, for 3 possible heads, we only have one possible outcome. So the fair one is a head, and the unbiased ones are both heads. We get 1 by 32. So we place the value of all the possibilities of the number of heads here. So for one head, it is 15 by 32. For two heads, it is 7 by 32. And for all of them being heads, it is 1 by 32. There we go. This is our probability distribution table. So in the next question, we're told at a company call center, 90% of callers are connected immediately to a representative. A random sample of 12 callers were chosen. Find the probability that fewer than 10 of these callers are connected immediately. So we're given the probability of success is 90%. So the probability that they were immediately connected is 0.9%. And the probability of failure would be 1 minus 0.9, so 0.10%. So how do we find the number of callers that were, so how do we find the probability that 10 or less of these, so how do we find the probability that fewer than 10 of these callers were connected? We could, now this is a huge number, so finding the probability would be almost impossible directly. So what we could do is we could find the probability that when more than 10 callers were connected immediately. So 10 or more, 10 callers were connected. So the probability that 10 were connected would be 12 out of 10, and 10 were connected and 2 were failed. And the probability of 11 callers being connected would be 11 were connected and 1 was failed. And another probability that 10 or above callers were connected would be all 12 callers being connected successfully. So there we go. They were all connected successfully. Now, what we could do is we could add these, and so 10 successful plus 11 successful plus 12 successful. Now we could add these to find the probability that 10 or more callers were connected successfully. And we could use this value right here, find the probability that 10 or less callers were connected successfully. So 1 minus probability that 10 or more were connected successfully would give us 10 or more would give us less than 10, the probability that less than 10 callers were connected successfully. So we deduct this right here from 1, so we deduct each of them individually from 1, and we get the probability 0.111. This is the probability of less than 10 callers were connected successfully. So let's go to number B. Now, for B, it says use an approximation to find the probability that more than 69 of these callers are connected immediately. So we can use normal distribution to solve this. So for that, we would need mean and standard deviation. So we can find variance using the formula NPQ. So for binomial distribution, this is the formula for variance, and this is the formula for mean. So we can place n, which is 80, so n equals to 80, and p is the number of successful, which is the probability of successful connections. So we find the mean, and we find standard deviation by NPQ. Now again, n is 80, p is 0.1, and q would be 1 minus p, which would be 0.1. So we find this as our standard deviation. So now we need to find the probability that 69 or more of these callers were connected successfully. So let's draw a standard deviation graph here. Now let's say this is 69 callers were connected successfully. This is the probability. Now we need to find this area, which is 69 or more. So what we do is we subtract 69 or less from 1. So we find the value of this by using the equation value minus mean by standard deviation. So we have our mean, we have our standard deviation. We get the value 0.932. Now we get the value minus 0.932, and since we're deducting, all right, so this is p minus 0.932. The minus is cut out, and this becomes plus 0.932. So we go to the statistical table, find the value corresponding to 0.932, and we get 0.8243, which is our answer and our probability for 69 or more number of callers being connected successfully. So the next question we're going to be looking at is 6C. Now in 6C they told us to justify the approximation in part B. Now what they mean by this is they want us to show that we can use normal distribution for this calculations. So a rule for normal distribution is that the number of possibilities of something happening and the number of some possibilities for something not happening both have to be greater than 5. So let's say out of n possibilities, p of them happened. So out of 80 possibilities, 90% of them happened. So that would be 72. Now the probabilities that it didn't happen, which would be NQ, equals to 80 into 1 minus 0.9. So that would be 8. So both of these are greater than 5. This is the logic we're going to be showing um, to validate the answer, that since both the number of times it happened and the number of times it didn't happen are both above 5, the normal approximation can be used. Okay, now let's move on to the next question, 7a. So in 7a, they told us, find the number of different arrangements of the letters in the word alligator in which the two A's and two are together and the two L's are together. So we have 9 letters. So A, L, L, I, G, A, T, O, R. And we're told that the two A's have to be together. So, and the two L's have to be together. So normally what we would do is we would consider each of these letters as a box. So, and we could arrange the box in different orders. Now, since we're told that A's and L's have to be together, we could consider them as one unit or one box. So the two A's are one box and the two L's are together one singular box. So now we have 1, 2, and then 3, 4, 5, 6, 7. 7 possible arrangements or 7 boxes. So we use 7 factorial, and whatever comes out in the calculator is our answer, which in this case is 5040. Now in B, they told us that find the probability that the two L's are together. So the two L's are considered as one singular box again, and that there are exactly 6 letters between the two A's. So assuming the two L's are one box, so let's take out the A's from the equation. There are 7 letters left. 1, 2, 3, 4, 5, 6, 7. So with 6 letters between the two A's can either be in this spot or in this spot. So they have 2 possible outcomes. And between the two A's, there could be 6 letters. So we have 7 letters, and considering that the two L's are together, they have to be together. They cannot be outside the A's because, for example, we place it like this. There is nothing else on the side. There's only one spot left on the side. So the two L's are 2 letters, so they can't be here. Or suppose we take this spot over here. So these are the letters, and the two A's are placed here with 6 letters between them. Oops, sorry. And there's only one more spot left for the two L's. So the L's have to be between the A's. So since we're considering the two L's as one box, the A's have 2 possible positions, and between them there can be 6 boxes, but since we're considering the L's as one singular unit or one box, we now have only 5 possible boxes. So between the A, there's 5 factorials for 5 possible arrangements between the A's, and the A's have two places to go. So the A's have two possible spots to be in. Between the A's, there are 5 empty boxes. And because there are only 5 letters left, taking out the L's and the A's, and 4 spots left. So let's say L takes one of the spots between the L's take one of the spots between the A's. All right, the A's are here. That leaves only 4 spots empty, right? And we have 5 more letters. So this would be 5 in combination with 4, and we multiply them together. So we have the possible arrangement for the random letters, the possible arrangement for the boxes, and the possible places for A to be in. Multiply them, we get 100 and 1,000 and 200. And we're told how many probabilities would there be where this situation with 6 letters between the A would be valid and the 2 L's would be together. So this is our possibilities. And now we find the probability by dividing them with total probability. So there are 9 letters. So the total possibility of combinations would be 9 factorial. And we place the possible outcomes of the conditions that we found above ratio, and we get 0.132. So this is our answer. So in 7C, the last question, we are told to find the number of different selections of 5 letters from the 9 letters in the word alligator, which contain at least one A and at most one L. So we're given 5 boxes, and cutting out the A's and L's out of the 9 letters, we have 5 letters left. So how many possible ways can we go? We could have one A and no L's. So there are 4 possible openings and 5 letters to place them in. So this could be a possibility. We could have one A and another A. We could have both the A's here and 3 openings. So 5C3, because there are 5 other letters excluding the A's and L's. We could have one A and one L and 3 other openings. 5C3 again, because there's 3 openings. Or we could have 2 A's and 1 L and 2 other openings. So this would give us a 5. This would give us a 10. This would give us a 10. And this would give us a 10. So adding up the possibilities, we get 35 possible ways where there is at most one L and at least one A. There we go. That is your question paper, all fully solved. I hope you understood every single question in here. If you didn't understand something or found something difficult, please ask away in the comments. I will be sure to respond to them. And thank you for watching.